Good day, everyone. I am Kimberly Payang, one of the reporters of Group 7. For today, we will be discussing a video presentation on management science, specifically on the topic of critical path method or the CPM. Before we move on to its definition, let me discuss to you first some terms that will be relevant on this presentation. We have here the project management. Managers have been planning, scheduling, monitoring, and controlling large-scale projects for 100 years. But it has only been in the last 56 years that management science techniques have been applied to major projects. There are two types. First, the critical path method, also known as CPM, which we'll be focusing for today. Second, project evaluation and review technique, also known as PERT. As part of our introductory, let me show you our table of contents. Today, we will be tackling the CPM's history, concept and terminologies, advantages, disadvantages, application, and of course, the summary. Now, let's start to take a peek on its origin. So, how does CPM starts? In the late 1950s, CPM was developed by Morgan R. Walker of DuPont and James E. Kelly Jr. of Remington Rand Organization as a project modeling tool. The initial critical path method was used for plant maintenance projects. DuPont put it into practice between 1940 and 1943 that helped the Manhattan Project succeed. The phrase critical path is credited to the creators of the PERT that was created about the same time by Booz Allen Hamilton and the U.S. Navy. So much for that. Here is a sample illustration of the application of CPM. But let's dig deeper. The question here is, what is a critical path method? It is a step-by-step project management technique for process planning that first identifies critical and non-critical tasks, second, preventing time frame problems, and third, process bottlenecks. It is also a technique where you identify tasks that are necessary for project completion and determine scheduling flexibilities. In project management, it's the sequence of activity between a project's start and finish that takes the longest time to complete. CPM is also based on mathematical calculations and it is used for scheduling project activities. The essential technique for using CPM is to construct a model of the projects that includes the following. First, list of all activities required to complete the typically categorized within a work structure. Second, the time or duration that each activity will take to completion. And lastly, the dependencies between the activities.
At this juncture, we will be familiarizing ourselves to the terminologies used in critical path method. It is in order for us to effectively explain its purpose, structure, and operation. As you can see, we also included here symbols of the concerned terms that are observable in the so-called project graph of this model for our own convenience. So first, activity. Activity in CPM carries the arrow symbol, which represent a task or subproject that uses time or resources. Event is denoted by a circle, marks the start and completion of an activity which also contain a number that helps to identify its location. Dummy activity, on the other hand, used to maintain the predefined precedence relationship only during the construction of the project network. It is represented by a dotted arrow and does not consume any time and resource. Lastly, parallel activity. It's wherein two activity being at same event and end at same event, meaning these two have the same start and completion time. However, it is not allowed. So now, what is path? Critical path and criticality index. path is a series of adjacent activities. Meaning, when we say adjacent, it's the preceding or the following activity, leading from one event to another. Basically, path talks about the total of the activities of the entire project. Critical path, on the other hand, is the sequence of critical activities that forms a continuous path between the start of project and its completion. It deals with the sequence of the critical activities from beginning up to ending. In other words, it's wherein activities are arranged. Remember, arranged in a particular or sequential order or manner. Criticality index shows how often a particular task was on the critical path during risk analysis. It is said that tasks with a high criticality index are more likely to cause delay to the project since they're more likely to be on the critical path. Now, let's talk about the earliest start time, earliest finish time, latest finish time, and the latest start time. How these terms different from one another. Earliest start time is the earliest time an activity can start. Remember this? Can start once the previous dependent activities are completed. Meanwhile, earliest finish time is the earliest time for the activity plus the time required to complete activity. Moreover, latest finish time is the latest time an activity can be completed, or remember this, can be completed without delaying the entire project. On the other hand, latest start time is the latest finish time minus the time required to complete the activity. Don't be confused to the definition of these two last terminologies. Just bear in mind or keep in mind that latest finish time is our keyword in the latest finish time is the word can be, an activity that can be completed without delaying the entire project. On the latest start time, it is the latest finish time minus the time required to complete the activity. Contrarily to earliest finish time, wherein in earliest finish time, we need to add back the time required to complete the activity. Whereas latest start time, we need to subtract or deduct the time required to complete the activity. At this point, when we say total float, it is the amount of time an activity can be delayed without delaying the entire project. Remember again, without delaying the entire project. Meanwhile, when we say free float, it is the amount of time an activity can be delayed without delaying the early start date of a successor activity. So, bottom line, total float didn't affect the entire project by still sticking on the target date or time for its completion, even though there might be an occurrences of some delays while accomplishing a certain activity of the project and might cause for the succeeding activity starts late. Meanwhile, in free float, it clearly states that the completion of the activity 3 of the project, for example, has been delayed, but it shouldn't cause the following activities late to start. So now, let's move on to the forward pass and the backward pass. When we say forward pass, it is the process to determine the early start or early finish times for activities in the critical path method. While backward pass, it is the process to determine the late start or latest finish times for activities in the critical path method. Just keep in mind that when we say forward, early start or early finish times. And when we say backward pass, we talk about the late start or latest finish times. We're now on the last part of the terminologies used in CPM. We have here network diagram, and network analysis. When we say network, it is a graphical diagram consisting of certain configuration of arrows and nodes for showing logical sequence of various tasks to be performed to achieve the project objective. Just remember that when we say network in critical path method, it is the graphical diagram showing us the logical sequence of the various tasks to be performed in the entire project. Now, network diagram, it is a schematic display of the relationships between project activities, which is always drawn from left to right to reflect the order of the project. Lastly, network analysis. It is the process of breaking down a complex project into components. These components are activities, durations, and etc. and plotting them to show their interdependencies and interrelationships. The critical path is the longest route through the network, but we also calculate the earliest and latest possible activity start times. This allows us to see where we have the flexibility to change the start time of an activity without affecting the project's completion. Slack in the plan is a term used by project managers to describe flow. Naturally, a project can have multiple critical paths. Indeed, if each path through the network takes the same amount of time, one may argue that the project has been optimized to minimize risk given that all resources are fully utilized. Note that if your network has parallel paths, you can only make this work if you have resource flexibility to ensure that your resources are used effectively according to your strategy or to your plan. Critical path method is a project modeling technique, right? So we have here the 60 steps in order to make this method or this technique be done effectively and efficiently. So we have here first, specify each activity. We usually draw this from our work breakdown structure. Second, sequence of the activities. So in order for us to know or to properly arrange the sequence of our activity, we must understand the patterns that connect one activity to the next, and this makes step 3 possible. What is this step 3? Draw the network diagram. Again, this is a graphical representation, employs arrows to connect the activities, which are shown as boxes and in which we can record the information that is essential to us. Next, estimate activity duration. Traditionally, in critical path method, they use a single point estimate, which has both strengths due to its simplicity and weaknesses due to the method's lack of contingency and variability recognition. Then, identify the critical path. This critical path is stated to be the network's longest path. It's crucial because any extension of an activity's duration due to a delay will always lengthen the critical route, hereby delaying project completion. And finally, modify your critical route to reflect progress and use it as a monitoring and planning tool. This is the last step, which is update to show progress.
From the previous slide, we have learned the meaning of critical path method, how it is used, and the following terminologies used in CPM. So now it is time for us to understand how CPM benefits its users. There are following advantages in using CPM. The first one in the list is effective scheduling. With the use of critical path method, we are able to plan our activities in a achievable manner. We can do the things that we have planned effectively because we critically think the things that we need to do ahead of time, so that we don't need to rush things out in doing our project. From here, we have already set our expectation to the present of the project that can help us to foresee its future. The second benefits is enhanced project management. Just like in the first advantage, CPM helps you to do things that will help you in improving your project. It allows you to identify tasks that are necessary for the project completion. Critical path will help you to finish the set activities on time to completely finish the project. The third one is distribution of human resources. CPM helps the management, specifically the project managers, to prioritize tasks, giving them a better idea of how to and where to deploy their resources that will definitely contribute in making their projects. And the last benefit is budget and cost control. The CPM analysis addresses issues of quality, efficiency, and cost reduction by standardizing work efforts and eliminating unnecessary steps to reduce time required in finishing the project that will result for the satisfaction of every customers. If there is a advantage, there is also the drawbacks of CPM or its disadvantages. The scheduling of personnel is not handled by the CPM. Because this happens because every personnel have their own rights. In setting their own schedule, they have the rights to complain. And when the CPM will be the one to handle this will seem to be unfair to them. The second one, in CPM, it is difficult to estimate the completion time. Even as people cannot foresee the exact time for the project to be finished because we do not know what are the things that might happen along the way in making of the project. CPM is only our help in managing this project. Third one, the critical path is not always clear in CPM. The critical path is not always clear in the CPM for there are things that is being joined to this. The fourth one, for bigger projects, CPM networks can be complicated too. CPM networks can be complicated because of the numerous information that is inputted here. The fifth one, it also does not handle the scheduling of the resource allocation. Just like in the first drawbacks, CPM cannot handle all the things that is needed in the project. There is only a specific subject that concerns the CPM or concerning the CPM. The sixth one, in CPM, critical path needs to be calculated precisely. Critical path really needs to be calculated precisely because this is needed in making your project successful, so that you can also avoid the malfunctions while finishing the project. How does critical path method works? For example, building a house. Here, your project is house building, and you really need to use critical path method in doing this kind of project. You need to make a precise plan, like your budget plan and the time frame of the project. CPM assists the project manager or the engineer to ensure that in building the house will be completed on time and within the budget plan so that you won't be short financially. And also with the help of CPM, you are able to make a schedule in doing every part of the house from lot excavation up to the finishing part of the house. Just here is the illustration. So now it is time to wrap it up. What to remember? We should inculcate in our mind that CPM has its own structure. A critical path method is a project management technique that entails sketching out all of the main tasks required to accomplish a project. CPM involves computation and analysis. It entails determining the amount of time required to complete each activity as well as any dependencies between in doing the project. CPM is realistic. It is a method for determining a realistic project deadline and tracking its progress. Just like the time frame or on or when to finish the project or on when will be the project to be finished by the project managers.